That's nice and quiet. Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and today we're taking a look at something here that I think is a fantastic blend of century-old firearms technology and cutting-edge modern manufacturing technology. This is a Radical Defense M249FVS suppressor, and it came about as a response to a request from US SOCOM, Special Operations Command, in 2019, looking for a suppressor that was capable of sustaining significant amounts of fire. You've probably seen, or you can certainly find if you haven't seen, videos of, let's destroy a suppressor from heat from firing a machine gun with it, for some ridiculous length of mag dump. Well, there is some validity to that in some circumstances. Very high volumes of fire in a machine gun can very easily damage, destroy, and otherwise cause problems with suppressors, and SOCOM wanted something that could handle that problem. So they put out a request for a suppressor that could handle a 600 round Mad-Minute magazine, belt dump on an M240 machine gun, and Radical responded with, well, not this. They responded with one that is 14% larger. Well, they responded with one that is larger for an M240, 7.62 caliber, and then as a side project on their own, they scaled it down 14% to this for the 5.56 M249. But what they have done here is coupled modern 3D printing technology with essentially the cooling shroud system from the Lewis gun. So let me show you a bit up close. There's not a whole lot to show you because, well, it's a tube, but I can show you how the cooling system works. We have two different elements at play here. One is the manufacture and the other is the design. Let's start with the design. Like the Lewis gun, this is built with a series of air cooling tubes essentially around the outside of the suppressor. So you can see the end in there and of course the other end here. And these are continuous hollow tubes that run along the entire length of the suppressor body outside of the baffle stack. And what those do is allow airflow across the baffles. Now, you may be wondering how that's like, you're not going to get much airflow through there. Well, the design here, like the Lewis gun, is set up so that muzzle blast, when you fire, is going to push air at relatively high pressure out this sort of nozzle of a front end of the can. And that is going to create a vacuum effect back at the rear end of the can and suck cool outside air into these tubes, run it through here, and push it out the front. So as you're firing, you get this forced air cooling effect. And it's actually a pretty substantial effect. In their testing, they got a little over 15 miles an hour of continuous airflow through the can. Now, what makes this even more interesting is that once the suppressor gets really hot, once it's over about 450 degrees, this effect will continue on its own without needing any muzzle blast to create it. And that's because of the physics of the pressure, the temperature differential between the inside of the can and the outside. The really hot inside will cause this airflow to continue. So if you shoot the gun enough to really heat the suppressor up, you sort of get double the cooling capacity because it'll keep cooling after you're done shooting. When they did their formal shooting testing with an infrared thermometer, they started with the can at 144 degrees, which to me means it was outside somewhere in the southwest and in the sun. And they put then a 600 round continuous burst through it, which by the way is enough to destroy most suppressors. At the end of that burst, the outside of the can measured 1,565 degrees Fahrenheit. After 10 minutes, that had dropped to 484. So an 1,100 degree drop just from that forced air cooling effect after the gun had ceased firing. 30 minutes after it ceased firing, it was back to 144 degrees, its initial starting temperature. So really impressive cooling capability. This is not to say that you can, dump a 100-round belt and immediately grab the suppressor. You can't. The purpose here is not to make it touch safe. The purpose is to allow the suppressor to be as durable in high sustained fire as the gun, and it does that really well. Now, the second aspect of this is the manufacturing. So it's one thing to have good cooling, but as I just explained, this can heats up to almost 1600 degrees, and you've got to have a pretty good material composition to withstand that in the first place. And they do. Instead of making this out of steel, or in fact even out of Inconel, they went with a high nickel alloy. It's over 50% nickel and has a significant amount of cobalt in it, which increases the heat tolerance of the material quite a bit. And it is an alloy that is capable of being laser sintered, which is to say, essentially, you reduce the material to a very fine powder and then assemble it. It's basically metal 3D printing. In fact, it is metal 3D printing. So the question that would arise is, how on earth would you manufacture this sort of geometry, especially with suppressor baffles inside? Well, 3D printing allows you to build this as a single monolithic unit without any seams in it, literally from the ground right up to the end. It's an incredibly cool application of modern manufacturing techniques. And frankly, without 3D laser sintering, there's no practical way that you could design something like this internal geometry. Of course, there is also a question of how effective is it as a suppressor, and the answer is it's right on par basically with everything else. The 308 version on an M240 at the shooter's ear creates a decibel level of 136.3. This 556 version off an M249 is more like 137, but perfectly acceptable, good suppression of noise. It's also interesting to point out that the 249 version actually cools itself better. You have to shoot more to bring this up to a really high temperature because the rate of fire on the 249 is higher than that of the 240, and that higher rate of fire actually draws more air through the can and gives it more efficient cooling while you're shooting, which is pretty cool. So there are a couple downsides to this. Weight is a big one. This can, in this 249 5.56 millimeter can, weighs in at a significant 2 pounds 7 ounces. The 308 can, I don't have the weight in front of me, but it's equally quite heavy. Radical is in the process of developing a second generation that is more efficient internally. They've reduced the weight by over a pound on the 308 and by half a pound on this guy, as well as making the can shorter while getting the same noise reduction and cooling effect. So this is something that I found at SHOT Show and I thought was really cool. So a big thanks to Radical Defense for loaning me this. This isn't mine, they just loaned it to me. These are really actually quite expensive. One of the downsides of cutting edge technology is it tends to be quite expensive. But my initial plan was to put it on a machine gun and use an infrared thermometer and show you some of that heat reduction and plateauing, and then realized that aside from the massive cost of that much 5.56 to actually do it with, I don't own a machine gun that can handle the amount of heat that this suppressor can. My really cool Lage Max 1115 is an AR-based gun, and it has a capability probably of handling 300 to maybe 400 rounds of sustained fire before the gas tube explodes, because it's an AR-15 style gas tube. So that plan kind of went in the scrap bin. At any rate, big thanks to Radical for the loan of this. Hopefully you guys enjoyed the video. I think it's really cool to see combinations like this of firearms technology ideas that have been around that can be repurposed, combined with modern manufacturing, and create a really interesting product like this one. So hopefully you guys enjoyed the video. Thanks for watching.